Sir, it's visible.
Okay. All right. We'll look into the topic where we stopped in the last class. Hmm. Box method. I have seen about this. Returning a value is done, and yeah, constructors we spoke, and we all know that constructor will be called whenever an object has been created. And with respect to the constructors, we saw about the parameterized constructor and the zero parameter constructor. Why do we use a constructor? A constructor is used to pre-initialize the objects, or with respect to the instance variables which we need for the objects. In order to initialize those, we use the concept. Yeah, and also spoke about this keyword. Whenever in the same class you have two particular variables, one is with the local variable and the other one is a class variable. If you want to use the class variable at the same place where you have the local variable, this can be distinguished between keyword, something called as a this. All right, so that we spoke in the last class. Uh, yeah. Next is about instance variables hiding. So, coming to the instance variable which we speak. Okay. Towards the instance variable hiding. Whatever the variables which we have should not be accessed by all the classes, right? This particular data which we have for the instance variable is very precious, in the sense these information are very much protected, because these instance variables sometimes hold in applications like banking, or in applications like any transactions, these variables will actually be holding very crucial or very important information. Yeah, of course, program will be written by yourself. Somebody else can always change it, or any rogue programmer may alter it also. Or there can be some viruses from other program which can uh, get this value, right? So they can penetrate, right? They can penetrate some false program which are called as some ransom, or it can be a worm, or it can be a virus, it can be a Trojan, any other human developed set of codes. They can penetrate into the control can penetrate into these Java programs, and these Java program with respect to the instance variable may be compromised at any time, right? So care should be taken that these instance variables should be hidden. It should not be seen for all the functions. It should be only for restrictive functions only. So as you know that it is illegal for two local variables with the same name inside the same or enclosed scopes. Interesting, you have the local variables or the global variables which we spoke. So yeah, we have some of the variables like width, height, and depth, which we have taken in the class of object. But the use was in the box constructor inside the box class. So this is a constructor again, right? So making use of the this keyword, right? So my variable, which was the width, has to be initialized to a variable of the class. So what happens is the local, whatever this instance variable which I have will be hidden, right? And whenever I use this, the class variable will be highlighted. But it can be of the width, or it can be of a height, or it can be of a depth. Okay. So why do we want to hide it? So hiding the variable can be using the keyword of this also. And we also know that this is actually accessing with the instance variable, which can be of the same name most of the time. So a word of caution: the use of this is such a content some. Yeah, there can be other case that you're actually changing the value of this instance variable. So most of the time, if you're not properly dealing with this, if you misunderstand about the width of local variable with the instance variable, you can lose the data. You can lose the data. All right. So care should be taken whenever you're dealing with respect to the instance variable. The next concept is about the garbage collection. Garbage collection topic is very simple. Um, at your home, usually you have garbage which is piling up, that is dust or unwanted things which is piling up every day. Do you keep it at the keep the same garbage at your home? What do you do? Question to all: what do you do with the garbage? Because every day garbage will be created, some plastic, some cover, some uh, uh, non-eatable item, or some of the, it can be some rubbish, right? So what do you do with it? Every day it just piles up. What do you do with it?
Get rid of it.
We have to throw it, right? Or we have to reassign the value for it, right? So in order to maintain the cleanliness with respect to the memory, right? So you may ask, what do you mean by cleanliness in memory? That means memory is not an infinite space which we have. It is a limited space, right? Every time an object has been created, a new object will be created in the memory, and that memory will be residing for a longer time, right? I'll give you a small example here. We have Facebook servers, WhatsApp servers. Do you think they'll be switching on and switching off per day or per week or per month? Once they start, it will be running towards the lifetime sometimes, unless until we have some defects in it, or unless until we have some upgradation in it, right? So these servers will be running months together and they will not be switched off. So whenever the system is not switched off for a longer time, your memory will be holding a large amount of objects or large amount of variables in simple term here. So these variables, if they pile up, even when there is no one who are using it, that means at some time these memory will exhaust. Exhaust in the sense we don't have space for new more variables or new more objects to be created. So it's just rubbish data which we are holding, which may not be utilized. And we are also hampering the memory. So in order to deal with that, Java has a beautiful concept, something called as a garbage collection. All right. So whenever you allocate a space using a new operator, a new objects will be actually created. And if you do not destroy the object once the work of the object is done, that means those objects will be residing on the memory space for longer time. So if the object is present in the memory for longer time, it may create another issue of not allocating new variables or new objects. For that, whenever your scope of the object is done, you have to delete it. So how do you delete it? You make use of a particular keyword called as delete or delete operator to delete off the new object which you have created. For example, if you have if you have created a new what was the object? Let's take the same example of box. Box one object is equals to new box. If this is the case, you are actually creating one particular variable, I mean one object, which is the name of box, and this box will permanently go and reside on memory, right? This box is no more used, but still there will be this object which will be referred. You don't want this to be present lifetime. All right. So you need to delete it whenever the scope of this object is done. So you can use it whenever you there in order to create, you use the new keyword. So whenever you want to delete, you can, whenever you want to take off this object, right? Delete it, this object, so that the space will be utilized. So you can use delete whatever the object which you have created. Delete the objects, sorry, object that was box one. So once you do it, this will be deleted. This has to be done manually, by the way. So every time we can't actually calculate how, oh, what is that we have created, or what is that we need to take it off, right? This should be running automatically. So that automatic process of deletion of objects is taken care by something called as garbage collection. All right. So I hope you people understood it now. So instead of me deleting the operator every time, I want a particular process to be done automatically every time. In other words, whenever we use the allocation, we use the deallocation process, which happens automatically. That is called as garbage collection, or it is also called as GC collector, which we actually use with the code. All right. So whenever we have unclaimed memory, only then we can use it. When we have the claimed memory, we cannot use it. As simple as that. So we have one particular program to deal with that. So something called as a garbage collector. So this is how the program looks. All right. So this is deliberately calling the system.gc, but we'll go back from the class. So which is the main class here? Garbage is the main class. So the next thing is we are creating some objects of some class. So the object of this class is obj. Obj is actually an object created of this particular class itself. So this object has been created a new space. So we have allocation for the object. Once this allocation of the object is done, this object will be given a unique code called as a hash code. This object will be given with a unique code which is called as a hash code. You can get the hash codes of any objects. It will be different for your information. And the next thing is, once you create that particular object, you have a hash code for it. And okay, then the object is made as null. Why? Because this is no more referring to any value. Whenever the object is no more referring to any value, that object will be subjected to deletion. Right? If I don't use this particular line, it will never be deleted. Why? Because for a PC is actually filled with terabytes of, gigabytes of data or memory, right? It has a very huge memory. This object here takes only some bits, or maybe 2 byte or 3 byte. It depends on whatever exactly. But when it comes to a server which does not switch off, and for your information, whatever the objects which you are creating within the program here, it will be residing in the main memory, and it gets deleted. And it gets deleted automatically whenever you are not using it. All right. So why I'm making it as a null is I'm no more pointing this object to anything else. I created it. I took the value. Then I'm not assigning anything to that particular object. So that causes a call for garbage collector. What you can do is you can delete what was the object. You can do this, right? So provided it will not no more be used. It will be no more be used. But the concept of garbage collector is whichever objects which is assigned for null, whichever objects which are assigned for null, those objects has to be taken off periodically, right? Your Java has a periodic making use of a garbage collector. So after some time, it will run the garbage collecting process automatically, so that whichever objects which have been assigned with null, those objects will be taken off. All right. So if you deliberately want to call the garbage collector, where you have to delete off the objects which are assigned to null, you can call system.gc. GC is a method called as a garbage collector method. which will be looking into whichever the objects which you have assigned with null or at is which has been assigned by the program by null, everything will be deleted. All right, so let's look into this particular program. Uh, Basically, this program doesn't do anything. Why? Because you're just creating an object, you're assigning to a null, and you're running a garbage collection. It will not give you any output to run, by the way. And here, I may have used this particular finalize method, which just creates this. I'll tell you why exactly I'm using this finalize method. Before that, I hope you people understood what I mean by a garbage collector. So I'll just so if I run it, it creates an object. Object has a hash code, and it came towards the next line of the executable garbage. So it created end of garbage collection. All right, so it just displayed. This is the concept of garbage collection, and I am also having another set of code here, which is also called as finalize method. All right, finalize method is a last executable set of codes, which can be some database connectivity, data close or open, closing of the database connectivity, or some file closing. Any of these operations which we have has to be executed at the end of each set. Why? Because you have an application, you open a particular file looking for some data. The data which is present, you use it. The data which is not present, once you use it, you have to close the file. The closing of the file usually we omit. Why? Because we have most of the things, most of the operations which we need to do using that particular object. So what happens here is, whenever you want to close it, a particular programmer may forget to close it most of the time. So if the file which has been opened by the program, if it is not closed properly, the file may corrupt, or it may not be, it cannot be used by any other programmer or any other code. So it becomes a dummy file. In order to avoid that, we put set of codes inside a method called as finalize. What it does is, it actually does few things. Even though you do not call it, that finalize method will be called. Okay, but whenever a garbage collection is happening, so sometimes an object which needs to perform some action when it is destroyed, that means we are closing it, we are deleting of some objects. For example, if an object is holding some non-Java resource such as file handler or a character font, they may want to make sure these resources are freed. That means it is no more utilized, no more used by anybody. To handle such situation, Java provides a mechanism called as finalization. By using finalization, you can define specific actions that occur when an object is just about to reclaimed by the garbage collector. So reclaimed by the garbage collector means whenever you're deleting it, few set of things has to be like worked. As I said, what will be the few activities which you want to work on? Like closing of a file will be one particular use of it, right? So closing of or all related codes related to the destruction, right, will be put under a code called as finalize. All right, I hope you people got it. So whenever a garbage collection is called, automatically it looks for a finalize method. So whenever a finalize method, if there is a finalize method, it should be a overriding the final method. I'll tell you why it should be a override. Why? Because we already have a finalize method inbuilt. That's what I said. Garbage collection will happen automatically at some time, right? So whenever the garbage collection is called by the user or a system deliberately by the user or a programmer, then you have to override the finalize method which was already there. by your own finalize method. Or else, even if you don't give the finalize method also, it will work fine. No issue. It's not like a compulsory which you need to give it. But when it comes towards a very large program, large information flowing, or servers which are running for a longer time, there we call the GC connector. So before calling the GC connector, this finalize method will be called automatically. Then only the GC connector will happen, and then only it moves further. Okay, so you'll get a very, you'll get the understanding provided you now use this code here. So this is a set of code here. What happens here is, so yeah, the program starts with the main, then object has been created, object has been used for by a program, then object has been assigned to null. That means that this object is no more referred by anybody. Then what happens? Then GC collector will be called. Okay, this GC collector will now see, do we have any finalized method which has been given by the user? Okay, if the method is present, if the method is present, then it will override that particular method. It will override this particular method. That means if you are giving this finalized method, then I will use it. I'll use the same method which you are actually giving. If not, I'll make use of my inbuilt finalize method. That's what simple it is. So here, whenever a GC is called, here few things has to be closed. That's what I'm telling you. Object opens the file, reads the information, does something inside a file, and it closes it. That closing will not happen whenever you abruptly call the GC collector, because that file might be referred by the object. So those closing of file or closing of some information, some path or whatever it is, the usage of resources. Yeah, this is the garbage collector which has come in my home now. The sound which you see now is the garbage collector. He comes every day at the same time. You getting this? So this garbage which I am generating now has to be given to that guy. Now he is taking it. So that is periodic. That is automatically done every day, right? So if my garbage is more, then I have to what? I have to carry it outside. That carrying it outside is what called as GC collector. And if you are carrying it, see to that you are not throwing the valuable stuff. That means you have to check you are not throwing any valuable stuff. That's what the finalize method will do. Okay, whenever you call this GC collector, before executing the GC collector, it executes this, and again it comes back to GC collector. It deletes off all the object which has been assigned. Then it will be executing normally. Do we have any doubts here, guys? Right, garbage collector guy has come at the right time. Any issues? Anybody has any doubts here?
No, sir.
Shall we run the program then? All right, we'll run it. So once we run it, as I said, the hash code of that particular object has been, which was created, it is there. Then we have the garbage collection. Then the finalize method has been, whatever, by the time it deletes, then the finalize method will be called. We also have another method which is called as final. We also have another method which is final, and this final and finalize, they both are a bit different. Okay, so this is what with respect to the garbage collection which I wanted to explain you guys, yeah, I think we have understood about the garbage collection. So if a particular question has been asked in the exam, the session what we spoke today should be completely put up on the paper. Most of the time you can expect this question, because garbage collection, garbage collector, most of the people will not may not uh, learn it clearly. Why? Because they just say that garbage collector collects or deletes the unutilized objects. But in case here, this is what happens. All right, moving on. The next case here is, all right, we also have some note here. remember these notes, whatever you see in any of the books or any notes, those are very important. So if you're familiar with C++, there you know that we have something called as a destructor also. So we have a constructor which is actually called as box, right? So destructor will also have the same, but it will have a tilde symbol in front of the in front of a constructor. Okay. In other words, it has a constructor which will be in this way, some executable lines of code. Destructor will also be there. So what is the name of the destructor? Destructor will have the same name as that of the constructor, and it will not return anything. But how do you distinguish between a constructor and a destructor? A destructor will have a tilde symbol. A destructor will have a tilde symbol. That destructor in C++, in other words, called as GC character or the finalize method, which it does. All right. Before the completion of a program, it needs to do few things. So that's what a destructor will do. So here, if you're familiar with C++, then you know that C++ allows you to define a destructor for a class which is called when an object goes out of scope. That means whenever an object has been assigned to null. Java does not support that. And in other words, the finalize method is approximately the same as that of the destructor. As you get more experience with Java, all right, you need see the need of destructor functions in minimal because Java garbage collection system, it's a subsystem because Java automatically takes care. Whenever Java gets to know that, Java compiler gets to know that, okay, we are towards very less objects at this time now, then Java will get to know that, okay, I have to call the garbage collector, then garbage collector will automatically run and it does its job. All right, that's about the garbage collection and finalize. All right, we'll take up this something called as a stack class. We'll look into some example code for it, and we'll wind up with the topic now. All right, this is not the complete program, but still I have redone the program and I'll explain it to you. But anyhow, before running it, you should know what exactly is a stack. A stack is a data structure which holds array variables in a given form. All right. So in other words, a stack is actually a data structure or similar to that of an array, but it works on a principle. What is that principle? A principle of stack is first in, last out. Okay, it works on a principle of philo, that is first in, last out. Whichever variable which enters this array first will be taken off at the last. For example, if I insert a value 10, 20, 30, 40, 50, I cannot take out 10 first. That becomes a cube, right? So stack goes in this way as I think I closed my presentation here. Yeah, sorry for that. Yeah, this. Now I guess we can do it. We have 10, 20, 30, 40, 50, which has been put up inside an array. And whenever you are inserting into this stack, so it also inserts the same way. 10 was inserted first, 20 was inserted first, 30, then 40, then 50. So my counter here is now at this particular position, which I call it as a top. Usually stack, you can name it anything, but usually for stack we use the variable which gives the position of current element or the last element. To be in stack, it is the last element. To get to know the last position of variable, we have a variable called as a top. So yeah, so which is in the top now. The top is 50. If you want to delete it, 50 goes first, right? So first comes the 50. First 50 will be deleted. So once you are deleting the value, what happens with respect to the top? Top will be now pointing here to 40. All right. Then whenever you delete this element, then which you see, then 30. Then if you delete 30, then you see 20. If you delete 20, then you see 10. Right. And we know that whenever there are no elements inside the stack, top will be pointing to -1. Top will be pointing to -1. That means this will be -1, and this will be 1 position, 2, 3. Sorry, this will be 0. This will be 1, 2, 3, 4, 5, and it goes on. So if I don't have any elements, then the top will be pointing out to -1. This is very much needed. So this is one concept of object-oriented program. So we'll be looking into how exactly it works in here. Okay. So the term of pushing or insertion, the term called as insertion of value inside my array is called as push. Is called as push. Deletion of any value from my stack is something called as popping, right? So insertion of elements into the stack, that complete term is called as pushing the term, and if you're deleting something, then it is called as popping. All right, so I guess this is the basic how a stack works. Let's see in Java how exactly it can do it. So this is one particular program. What it does is, he says that an integer stack, that means the stack is an integer, which you can see int here, that can hold 10 values, array with 10. Stop me whenever you're not finding it out or you're not getting it. All right, I repeat it on each and every class. Why? Because this is for your benefit. I need more time, more syllabus. I'm not telling it as we have a very vast syllabus. We have good amount of syllabus which have been framed, but whenever I speak in terms of with the explanation and coding, it takes more time. That's what I say. So I'll be in a bit good pace. I don't say it as I'm in a very fast pace. I'm in a very good pace where a normal people can understand, but still there might be some small here and there where you may have not concentrated at this time. So don't go anywhere. Be within the session with me. All right. So as I told you, this is a program. This is an integer program. So how do I know that it is an integer stack? My array here will be of the data type int. So the next thing is, how many elements do I have in this stack? I have 10 elements. Stack is also an array. Don't confuse yourself, right? Stack is just a concept by making use of array very well. All right, so in a stack we also need a pointer variable, which we call it as a top. Right here he has taken it as a toss, no issue. Okay, initially my stack will be empty. That means toss will be pointing to -1. That means my toss will be pointing to -1 because array element starts from 0, 1, 2, start from 0 basically, right? So next term here is, this is what is this method actually? Can anybody tell me what exactly this method is? Anybody? Look into the name of it. Look into the class name. So it's a constructor. Whenever you whenever you create an object of this stack, automatically this stack will be assigning with an array value of 10, and its top will be assigned to -1, because every new stack will be an empty stack, as simple as that. Next thing is, okay, I hope you got this. Next is pushing an element into a stack. That means you need to insert an element into it. Concept is very simple. If toss is equal to 9, that means the stack is full. That means you don't have any more elements which you can push it, because toss is actually starting from 0 and you know it can hold only 10. That means 0 to 9 is my 10 elements. So toss will be equal to 9. That means stack is full. You can't actually insert it. Else, that means your toss will not be 9. It will be lesser than 9. If it is lesser than 9, stack will be incrementing the value. This is pre-increment. Remember, pre-increment is nothing but first add first add the value, then assign the value. So you are adding the value, adding the value in the sense you are incrementing the toss to 0 for the first case. So you're incrementing toss for the 0th case. Then you are inserting the item. What is that item? The item is sent by someone here. Yeah, that someone will be your main program. So here that main program is okay, somewhere here. So we have some stacks here. So yeah, my stack dot push of I. So I initially will be 0. That means it is pushing the 0th element. It is pushing the 0th element. So once you insert 0 here, the item which it is getting is 0. So it is inserting the 0. So next is the popping is the another term. Popping in the sense it will delete it. And always whenever you want to delete any item, your top should not be less than 0. If your top is less than 0, that means I don't have any elements in my stack. And I cannot delete any elements if my stack is empty. So that's we are just checking it out. If toss is less than 0, that means stack is underflow. That means stack is empty. If it is not less than 0, that it should be greater than 0. That means you have to return what is on the top of the stack, and then you post decrement. Post decrement in the sense you give the value, you return the value, and then later you decrement your toss. Whenever you're deleting, if I say I'm deleting the 0th element here, you return what element you are deleting, and then toss will be pre-decremented. That means it will be now pointing towards what? -1 again. All right. So this is the working of the stack here. So yeah, that's what we looked upon. We looked into the push, we looked into the pop. I have explained you a small concept here of push and pop. I have a small program here which I'd like to explain you how the term actually works. All right, I have just took it as a small working program here. You can say public class stack. Stack has maximum size, stack array, and top. And here, this is my what? This is my constructor. I hope you people are finding it easy. So max size is equals to yes. So whatever the maximum size which you are sending, that will be for it. So initially, whenever you're creating an object, the object, you are sending some value, that is 10. That means it's a parameterized constructor. So the 10 value will reside here, and it will initialize the max size as 10. If you want to change it to 20 maximum size, you can push 20. That is also possible. Then stack array will be assigned to the maximum size. What is the maximum size? 10. And I am initializing my top as -1. You can do in this way also. That means you can give different object different size of the stack. That is the beauty of this program. You are actually giving different sizes for different objects provided whatever value which you send. For my next particular stack, if I make it as 20, then that particular object will be having 20 spaces. I hope we don't have any issues here. Okay, as I said, execution starts from main. The object has been created, and we know the constructor has been called with the parameterized. It was it saved what? It saved the value of maximum size, and it created the array of maximum size. It initialized top to -1. So the first thing is the stack dot push. So object dot push. It looks for an object. It looks for a function push with a parameter 10. So is there a function called as push here? Yes. So it is coming to push here. In the push, we have some value that was 10. So stack array of top increment, that is incrementing the top, will be equal to the j term. That means in my stack, the first element will be 10. Next, you're also pushing again 20. You're also pushing the value 30, 40, and 50. So 10, 20, 30, 40, 50. values has been pushed, and here once you push, you also need to check before pushing whether the element, I mean, you're on top of the stack or not. But this particular program is a small program which doesn't do that, which only pushes it, and we are only popping the value. All right, so stack with 10, 20, 30, 40, 50. So while not the stack is empty, this particular code says that if the stack element is empty or not, right? While the stack is empty, that means you are not pushing anything. Then is empty refers to if the element, if the stack is empty. Not empty means what? That should be taken. That is the true case here, right? So is the stack empty? If it is -1, if the stack is empty, it returns -1. So if it is returning -1, then it is not true, not -1, not true, right? So then it comes here. Then it not true in the sense that means the stack is empty. If it is not true, then the stack is full. So what it is, then it says that value will be equal to the stack dot pop. So the stack dot pop will delete the element, right? So the pop element will delete an element. So it will return what it is actually deleting, and it will be hold to the value, and the value will be printed, and it will be with a while statement. All right. So basically, you are pushing the elements 10, 20, 30, 40, 50, and while deleting it 50, 40, 30, 10, 20, 10, it will do this operation. Let's look into that. So pushing term is not, we are not displaying it. We are displaying only the popped element. So if I run it, so as I said, which was inserted first? 10 was inserted first, later 20, 30, 40, 50, and it started deleting the values from top. That means it started deleting the top element, that was 50, 40, 30, 20, 10. So for your easy understanding here, I'll just insert few more where I'll take it as 60 and I'll take it as 70. So if I run it, 70, 60, 50, 40, 30, 20, 10, that means from the top, it is actually deleting it. All right. I think that's about the easy working of, or the demonstration with respect to the stack. So in our next class, we'll be looking into the term of the important concept of what can be the enhanced version of objects and classes.